Hello, let me start with a simple question. What if Excel didn't stop at Excel? What if the spreadsheet you trust for business critical logic could turn into real software? Not a screenshot, not a macro, not a fragile export, but actual source code. That is Codcel. Codcel takes Excel and turns it into production-ready software in minutes. Full calculation engines, full web user interfaces, RESTful servers, AI-ready MCP servers, generated in real programming languages, Rust, Java, Kotlin, Swift, Python, C#, Visual Basic, Go, not pseudocode, not low-code blocks, actual source code that you own that you can read, test version, and deploy. This is what low-code was supposed to be, before it became, well, a very expensive box of limitations. Now you might be thinking, okay, sounds nice, but how real is this? So today, we're not doing a demo, we're doing a stress test, a ridiculous one. Today we're taking on the 1 billion row challenge. Yes, 1 billion rows. This challenge is famous in engineering circles because it looks simple and then quietly ruins your weekend. The task is straightforward on paper. You're given a file with 1 billion temperature measurements. Each row contains a weather station name and a temperature value. Your job is to calculate the minimum, the maximum, and the average temperature for each city. Sorted. Rounded. Correct. Sounds easy. Until you realize this file is massive. The data does not fit nicely in memory. The performance constraints are brutal, and most systems slow to a crawl or simply give up. Entire teams have tried this. Frameworks have tried this. Low-code platforms have politely declined. And that's exactly why we're doing it. Because Codcel doesn't just generate code that works, it generates code that scales. In a moment, you're going to see Codcel generate a full web application from Excel that can process 1 billion rows and instantly tell you the minimum, maximum, and average temperature for any city you type in. No hand-written optimization, no magic runtime, no hidden services, just Excel in, real software out. Let's see what happens when spreadsheets meet reality. All right, let's start where all good ideas begin. Excel. Here's the spreadsheet. It has 2 sheets. The first one is called T_measurements. Now this underscore matters. In Codcel, any sheet that starts with T_ is automatically treated as a table. Not a suggestion, not a hint, a real table with full accessing code. This table has 2 columns, town and temperature. Below that, the data, completely unsorted, intentionally messy, just like real data. Row 2, Palm Springs, 21.2 degrees Celsius. Next one, Skopje. Did I pronounce that correctly? No idea. But Excel doesn't care, and neither does Codcel. And it goes on like this. Town, temperature, random order. Now, if you're an Excel expert, your brain has already raised a red flag. Excel can't handle 1 billion rows. And you're right, Excel tops out at a little over 1 million rows. Codcel can handle 1 billion rows. Microsoft politely declines. So how do we deal with that? We don't fight Excel, we work around it. The 1 billion rows are stored in a CSV file, not inside Excel itself. In this spreadsheet, we only included a small sample, about 1,000 rows, enough to design, test, and validate our calculations. We scroll down, and it ends at Austin. That's fine. We don't need the full dataset here. We just need enough structure to describe what the calculation should do. Now let's jump into Codcel. Here I've already added 2 files, the Excel spreadsheet we just saw, and a CSV file called T_measurements.csv. Here's the clever bit. If Codcel finds a CSV file with the same name as a T_sheet, it ignores the Excel values and loads the data from the CSV instead. Same structure, same columns, different scale, which means we can write calculations in Excel as if the data is small, while Codcel runs them on a dataset that is very much not. You might still be suspicious, so let's remove all doubt. We click Open Business Specification folder and open the CSV file in RustRover. RustRover tries its best. Then it politely tells us the file is too large. 13.8 gigabytes. Read only. That's a good sign. And inside it, exactly what we expect. Town names, temperatures, completely random order, over and over again. No tricks. Now, let's go back to Excel and look at the actual logic. The calculations live on the first sheet. We have town as an input, defined with a simple Codcel tag. We've set it to Miami, so we can see real results. Then we have 3 outputs, min, average, and max. Again, just small Codcel tags, nothing exotic. Let's look at the max formula. We filter the table so we only keep temperatures for the selected town. Then we apply the max function. And finally, we round to 1 decimal place. That's it. For Miami, that gives us 42.2 degrees Celsius. Average works the same way, just with average instead of max. Minimum, yes, it uses min. At the bottom, we combine all 3 results into a single output. And that's important, because when we generate the web UI, one request returns all 3 values, minimum, average, and maximum. Simple Excel formulas. 1 billion rows. Next, we're going to let Codcel turn this into real software. All right, let's go back to Codcel. This is the moment where things usually get complicated. We click Generate Project. And this is where Codcel quietly shows what it actually does. From this one Excel file, we can generate a lot. A Rust RESTful server, a full web client, OpenAPI documentation, command line tools, an AI-MCP server, and we can generate them in multiple programming languages, JVM languages, .NET languages, Python, Go, JavaScript, Swift. More coming soon, because stopping would be rude. And yes, you really do just tick a checkbox. No configuration maze, no wizard asking you 17 questions you didn't want to answer anyway. For this demo, we're going to generate a Codcel Dioxys full-stack UI. As soon as we select it, you'll notice something. The foundation modules, including tables, are automatically selected because Codcel already understands what your spreadsheet needs. No manual wiring, no don't forget this dependency moment. Let's scroll to the bottom and click Generate. Now, this is usually where someone tells you to go make coffee and come back tomorrow. This table is large, very large, but this isn't going to take days. It's not going to take hours. It's going to take a few minutes. Just enough time to sit back, relax, and briefly wonder why this feels too easy. And there it is. Project generated successfully. No warnings, no footnotes, no some features may not be available. We just turned an Excel file into a full production-ready web application. Before we run anything, let's look at what Codcel actually generated. We go to Codcel Tables and click the Tables tab. In the Project Explorer, you'll notice something interesting. We don't have one gigantic table file. We have many T measurements, read-only table files. In the calculation logic, this still behaves as one table, but under the hood, Codcel has split it up so each file stays a sensible size. Let's open one. This single table file contains 10 million rows, and we have 100 of these files. They're numbered from 0 to 99, 10 million times 100. That gives us 1,000 million rows, which is 1 billion. At this point, I'm going to ask the obvious question. Do you believe me now? Inside the table, you can see exactly what you'd expect. Town names, temperatures, completely random order. No pre-sorting, no cheating. And because this is Codcel, we can even run SQL queries directly against these tables. Right here, no external database tools, no exports, no open this in something else. Everything lives in one place. Now let's switch to Codcel Full Stack UI. We click Source Code, and here it is. Front end, back end, all of it. Written in Rust, using Dioxys. We open source, then back end, then components, Rust files, lots of them. All generated automatically. This is not a mock-up. This is not a locked platform. This is full source code. You don't have to understand it, but you absolutely can. Now, just before we run this, you might be wondering, how do I actually install all of this and run it on my own machine? Let me show you quickly. We go to codcel.io and click Quick Start at the top. You'll see different guides depending on who you are. For the web UI, we select Spreadsheet Hero. There's a clear step-by-step guide, and for every step, there's a short video. If you're a Java person, pick Javist. If you live in .NET, pick the .NET guide. Python, Go, Swift, choose your comfort zone. All right, let's go back to Codcel and actually run this thing. We click Run in Terminal. Now we wait a moment while Rust compiles and the web app starts. This is the calm before the storm. Next, you'll see what 1 billion rows looks like when Excel turns into software. All right, it's running. We see the message, serving at HTTP. Let's copy that and open it in the browser. And here it is, a clean start page asking us to select calculation. We choose temperatures. That's the combined output of minimum, average, and maximum. We click Go. Now we see the input field, town, exactly like the Excel file. Let's enter Hamburg and press Run. Now we wait, just a few seconds, and there it is. Minimum, average, maximum. Now, that maximum of 62 degrees and minimum of minus 39.6 might look a little suspicious, unless Hamburg has quietly relocated to another planetary system. But this is expected. The temperatures in this file are randomly generated. They're not real-world weather data. So let's verify it. I wrote a small program outside of Codcel that scans the CSV file directly and extracts all Hamburg entries. Let's take a look. Here are the values, sorted by temperature. The minimum minus 39.6. Scroll down, and the maximum 62. Exactly the same. And notice this. There are over 11,000 rows just for Hamburg alone. Now, you might be thinking, a few seconds feels a little slow. And that's a fair instinct. Until you remember what just happened. This data is completely unsorted. There is no index, no pre-aggregation, no shortcuts. Codcel scanned 1 billion rows and computed accurate results on demand. That's not slow. That's impressive. And more importantly, it's predictable. It scales. And it's real. This is Excel logic running as serious software with a real web UI, real performance, and full source code. This is what happens when spreadsheets grow up. This is Codcel. Excel in, real software out. To keep exploring Codcel, visit us anytime at codcel.io.